So intensity is the amount of power delivered per unit area. So I is our intensity, and that's in watts per square meter, right? That makes sense, right? Power is just power, literally. I mean, this is kind of one of those weird formulas with words in it, you know. Okay, and then area is square meters, right? Be careful when you calculate area, right? If it's in centimeters, turn it into meters first. So, for example, if it's say 82 centimeters by, if it's rectangular, right, and 45 centimeters, do it. Don't multiply and then try to convert. Go 0.82 by 0.45, and that'll give you the square meters. Okay, let's do an example of this here. Okay. Okay, if the solar constant, okay, so this is kind of fun, right? This is how much, this is the intensity of the sun, and this is, you know, I don't know, this is New Mexico on a clear day or something like that. And by the way, it's really not a constant. As the sun goes through its like sunspot cycle, and there's a lot of sunspots, the sun is actually heating up, which is funny because sunspots themselves are cool areas on the sun. But anyway, you'll have to take astronomy. But anyway, let's suppose that the intensity of the solar flux is 1,360 watts per square meter. What is the power incident on a solar panel that measures 1.98 meters by 0.99 meters and is facing directly into the sun? So we've got the sun is right overhead. This never happens, by the way, in Oregon. The sun is never directly overhead. It only happens between the two tropics on the globe. That's what they mean. All right, but anyway, let's imagine that we're below the whatever the tropic is that's closest to us and close to the equator. The sun is shining straight down, and we're looking for the power. Well, if I is power over area, right, then power is intensity times area, right? So this is the power is going to be 1360, and that's watts per square meter. And then that's times 1.98 meters by 0.99 meters. Okay, so this thing right here, that's my area, right? So if I do my area, if I go 1.98 times 0.99, I get the area as 1.99602 square meters. If I multiply that by 1,360 watts per square meter, I get a lot of watts, 2,665.872 watts. Okay. Now that is the power that's available. Solar cells, this is a typical efficiency. Solar cells are about 20% efficient, right? And by the way, the 22.8 efficiency that's listed by the manufacturer of these solar cells, that's when the solar cells are cool, right? If the solar cells heat up, and they do heat up because they're on the roof of your house, they get less and less efficient. So PV is not the most efficient, right? But anyway, if they're 22.8% efficient, how much power do they generate? That's easy, right? Let's see, efficiency is what, power output over power input. This is our power input, right? So we just go efficiency times power input is our power output. So 0.228, that's 22.8%, right? Times 2,665.872. So times 0.228. And I get 607.8 actual watts of power, which is nothing to sneeze about, right? That's a lot of power. Yeah, it'd be power that would just turn into heat if it was shining on your roof instead of those solar panels. I think that's it.